close your eyes. The quiet science begins. Tonight, we gently drift into Did the Big Bang Even Happen? Others calm your eyes, are quietly receiving light. Right now, that has been traveling toward you since before the Earth existed. And the question of where that light truly began has no simple answer. There is nothing you need to do right now, not figure out, not follow carefully, not remember. Whatever the day carried, its weight, its obligations, the particular texture of whatever you were solving or carrying or trying to hold together, you can set it down now. Not permanently. Just here. Just for a while. It will be exactly where you left it if you need it again. But right now, there is only this. You are lying down, or sitting, or somewhere between the two. Your body is in contact with something solid, a surface that holds you without asking anything of you. Notice that, if you like. The solidity beneath you. The way it simply accepts your weight without negotiation. Breathing is already happening. You don't need to change it. You don't need to deepen it or slow it, or pay it any particular quality of attention. It is doing what it has done every moment of your life, even while you slept, even while you forgot entirely that you were a body at all. It continues regardless. There is a question we are going to spend some time near tonight. Not solving. Not answering definitively. Just sitting beside it. The way you might sit near water, without needing to understand the full chemistry of what makes it liquid. The question is simply this: did the universe begin? That sounds like it should have an answer. It sounds like something science settled long ago. A textbook entry, a confident paragraph with a date and a diagram. And in one sense, there is a story most of us know. An explosion, a beginning. Time itself starting from some single impossible point. But the honest version of that story, the version the physicists themselves tell when they are being careful, is quieter than that. More open. More alive with uncertainty than the classroom version ever suggested. And that uncertainty is not a failure of knowledge. It is, quietly, one of the most interesting things about the question. Your body is warm in some places and cooler in others. The air touching the back of your hands is probably slightly cooler than your core. This is ordinary. This is how a body distributes itself through space, holding its own chemistry, maintaining its own small temperature against the surrounding world. You have been doing this your entire life without thinking about it. There is something worth staying with for a moment. The atoms that make up your hands right now, the carbon, the oxygen, the hydrogen arranged into cells and tissues. Those atoms are old. Not old in the way a building is old or a mountain. Old in a way that makes geological time feel recent. The carbon in your body was forged in the cores of stars that burned out long before our sun existed. The hydrogen is even older than that. Some of the hydrogen atoms in your body may be among the oldest things in the universe. If there was a beginning, if something we might call the Big Bang happened, those hydrogen atoms were present at its earliest moments in some form. They have been traveling, combining, separating, becoming part of stars and gas clouds and oceans and living things ever since. You carry that history in you right now, without effort, without awareness, simply by being made of matter. Most of us move through life without once considering this. We think of our bodies as personal, recent, local. We forget that the material composing us arrived from somewhere enormously far away and enormously long ago. Forgetting is not a mistake. It is how ordinary life works. But here, in this quieter kind of attention, there is room to remember it briefly. The hydrogen has been here for a very long time. You are, in a sense, a recent arrangement of something ancient. The story of the Big Bang, as most people have heard it, goes something like this, roughly 8 billion years ago. All of the matter and energy in the observable universe was compressed into an inconceivably small, inconceivably hot point. Then something happened. It expanded. Rapidly, then less rapidly, then more slowly over billions of years, until eventually there were stars and galaxies and planets and oceans and creatures that could lie down at night and wonder about it. That version is not wrong. It is, in most of the ways that matter for daily understanding, a reasonable approximation of what the evidence shows. But it is incomplete in a way that most people never hear about. The theory itself, the mathematical structure underneath the familiar story, breaks down at that supposed beginning. The equations that describe the universe's expansion work beautifully for most of cosmic history. They become elegantly accurate when applied to the early universe, when everything was hot and dense and before stars existed. But pushed all the way back to the very first moment, to what scientists call the initial singularity, the math stops functioning. It produces infinities. Infinities in physics are usually a sign that a theory has reached the edge of its own validity. This does not mean the universe did not begin. It means that our current tools cannot describe whatever happened at the very start, assuming there was a start. The beginning, if it happened, is technically beyond what we can currently see or calculate. This is not a problem that is being hidden. Physicists say this openly in journals and lectures, with the particular calm of people who have made a career of sitting with unanswered questions. It is simply the current state of knowledge. The Big Bang Theory describes the evolution of the universe from an extremely early moment onward. What happened at, or before that, moment remains genuinely open. There is something about that openness that, once you sit with it, feels less unsettling than you might expect. We live in a culture that tends to treat open questions as problems to be solved. gaps in knowledge feel uncomfortable, like something missing that should be there. But in science, the actual practiced science, not the textbook version, open questions are often where the most alive thinking happens. They are not voids. They are edges. The beginning of the universe is one of the great edges. And there are serious, careful, working scientists who spend entire careers exploring what might have happened there. Not because they are chasing mystery for its own sake, but because the question is genuinely tractable in certain directions. Mathematical, observational, slow, methodical work. One of those directions involves asking a question that sounds almost too simple. What if there was no beginning? Not in a dismissive way. Not as a way of avoiding the hard question, but as a legitimate possibility that certain theories take seriously. What if the event we call the Big Bang was not an absolute beginning, but a transition? A transformation from some prior state into the expanding universe we observe. This possibility has different names in different theoretical frameworks. Some physicists call it a bounce. The idea that the universe may have contracted before expanding. Others speak of it in terms of a quantum creation event. Something weirder and harder to picture, where the ordinary rules about before and after no longer apply. Cleanly, none of these are fringe ideas. They are published, peer-reviewed, actively debated. They exist not as alternatives to careful thinking, but as the product of it. The universe's origin remains one of the most genuinely open questions in all of science. And tonight, that openness is not something to resolve. It is simply something to rest near. When light enters your eye, it triggers a cascade of chemistry that moves from your retina through layered structures toward the part of your brain that builds what you experience as sight. This happens in roughly 10 milliseconds. You have no access to the process. You only receive the result, the sense of seeing, the light arriving at your eye right now. If there is any, even the faint ambient kind, has a history. Photons have a curious relationship with time that differs from objects with mass. As far as the physics can describe, a photon does not experience duration. From its own frame of reference, if such a thing can be said to exist, it arrives at the moment it departs. The journey between a star and your eye, however many light years it covers, collapses to nothing from the photon's perspective. This is not a metaphor. It is a genuine consequence of special relativity, the same physics that describes how GPS satellites need to be corrected for time differences caused by their altitude and speed. Light, in a technical sense, has no age. The light you received today from the sun left the solar surface 8 minutes ago by your clock. But the sun's light began as energy deep in its core, produced by nuclear fusion, and spent roughly 100,000 years working its way outward through the dense solar interior, before it ever became the kind of light that could travel freely through space. So the light that touched your skin today is, in a sense, ancient. And the question of when it began, when the chain of cause and effect that produced it first started, reaches back much further than a single morning. Everything has more history than its surface suggests. Your body, the light, the air, even the question you are resting near tonight. All of it arrives carrying something older than the moment it appears in. That is enough for now. Just that. Just the ordinary depth of ordinary things. The universe is not silent. This is something that tends to get lost when people think about space. The popular image is one of absolute quiet, a vast dark emptiness, planets and stars, separated by incomprehensible distances, nothing to carry sound through the vacuum between them. And that is true, as far as sound in the ordinary sense goes. If you were floating in open space, you would hear nothing. The medium that sound requires, something to compress and release, to pass the vibration along, is simply not present in most of space. But the universe carries something else, something that behaves in certain mathematical ways, like sound, and whose traces are still detectable today, if you know where to look. In the very early universe, before stars existed, before even atoms had fully formed, the entire observable universe was filled with an extraordinarily hot, dense plasma. Not a gas. A plasma, a state of matter, where electrons have not yet settled into orbits around nuclei, where everything is charged and interconnected. In this plasma, pressure waves moved. Enormous, slow compressions and expansions, moving through the primordial material, like sound moves through air, but on scales that make the Earth look like a grain of sand. These waves left marks. When the universe cooled enough for atoms to form, roughly 380,000 years after whatever event started the expansion, the plasma released its light. That light is still detectable today as the cosmic microwave background radiation, a faint, nearly uniform glow arriving from every direction in the sky. And embedded within that glow are subtle patterns, slight variations in temperature, mapped by satellites over decades of careful measurement, that correspond to where those ancient pressure waves had compressed and expanded the primordial material. The universe still carries the imprint of its own earliest sound. Those temperature maps of the cosmic microwave background are among the most carefully studied images in the history of science. Teams of physicists have spent decades building instruments sensitive enough to detect temperature variations of 100,000th of a degree, differences so small they strain the imagination. And from those variations, from that faint ancient patterning, they have derived extraordinary precision about the universe's age, its composition, and the overall shape of its expansion. This is what gives cosmologists their confidence when they speak about the universe's history. It is not speculation. It is measurement. The data is extraordinarily detailed, and the standard model of cosmology, the Big Bang framework, fits it with a precision that should, by any reasonable standard, produce quiet astonishment. But here is the part that is easy to overlook. The cosmic microwave background tells us about the universe roughly 380,000 years into its expansion. Before that moment, the plasma was opaque. Light could not travel freely because it kept colliding with charged particles. So the background radiation is, in a very real sense, a wall, a horizon beyond which electromagnetic observation cannot currently reach. Everything before that moment, the first 380,000 years of the universe's expansion, and any question about what came before the expansion itself, lies behind that wall. We have never directly observed the first moments of the universe. We have inferred them, carefully and with great mathematical rigor, by running our well-tested equations backward. But inference is not observation. The wall is real. There is something honest and grounding about that. The humility built into the best cosmological thinking acknowledges this. The wall exists, and the scientists know it is there. Somewhere in the history of how we talk about the Big Bang, the uncertainty got smoothed over. The textbook needed a clean story. The documentary needed a confident narrator. And so the standard account became something that sounds more finished than the scientists themselves believe it to be. This is not a conspiracy. It is simply what happens when complicated, probabilistic, uncertain knowledge gets translated into accessible language for general audiences. The edges get softened. The open questions get moved to footnotes. And most people end up with the impression that the origin of the universe is basically settled, pending a few details. The details, it turns out, are where most of the interesting questions live. One of those questions involves what physicists call the flatness problem. The universe we observe is geometrically flat, meaning that parallel lines, extended to enormous distances, do not converge or diverge. They remain parallel. This is a measurable thing, and it is, on reflection, surprising. For the universe to be as flat as we observe it, the initial conditions at the very earliest moments would have had to be tuned to extraordinary precision. Slightly more curved in one direction, and the universe would have collapsed back on itself long ago. Slightly more curved in the other, and it would have expanded so rapidly that matter could never have clumped together into galaxies, stars, or anything at all. The flatness we observe requires an early universe that was calibrated, in some sense, with extraordinary exactness. This is part of what the theory called inflation was developed to explain. Inflation is the idea, now more than 40 years old, and still actively debated, that in the very earliest fraction of a second, after whatever the beginning was, the universe underwent an extraordinarily rapid expansion. Not the ordinary expansion that has continued ever since, but something vastly faster. An expansion so extreme that regions of space that were originally in contact with each other were pushed apart faster than light could travel between them. This is allowed by physics, incidentally. The restriction on faster than light travel applies to objects moving through space. Space itself can expand at any rate. Inflation, if it happened, would explain the flatness. It would explain why the cosmic microwave background is so uniform. Because everything we can observe today came from a region so small before inflation that it had time to reach a consistent temperature. And it would explain the origin of the slight variations we see in that background. Quantum fluctuations, in the language of physics, stretched to enormous scales by the inflationary expansion. Those quantum fluctuations, inflated to cosmic size, became the seeds of everything. The slightly denser regions became the sites where matter eventually gathered, where galaxies formed, where stars ignited, where planets condensed, where life eventually arrived and began wondering about its own origins. The largest structures in the universe may trace back to effects smaller than any scale we can directly measure. This is the part I keep returning to, quietly, that the very largest and the very smallest are connected in a way that still feels worth sitting with. Inflation solves several problems elegantly, but it introduces others. One of the more unsettling implications of certain inflationary models is something called eternal inflation. In these models, once inflation starts in a region of space, it does not necessarily stop everywhere at once. Some regions stop inflating and settle into an expanding universe like ours. But other regions keep inflating and keep inflating indefinitely. In this picture, our observable universe, everything we can see, every galaxy, every star, the full 93 billion light-year span of the observable cosmos, is a single bubble that stopped inflating. And it may be surrounded by an endlessly inflating space in which other bubbles are constantly forming. Each bubble its own universe, with its own physical constants, its own history, its own possibilities. This is the multiverse idea, or one version of it. It is not science fiction. It arises as a mathematical consequence of certain well-motivated inflationary models. But it is also, currently, untestable in any direct observational sense. If other bubble universes exist, they are beyond our cosmic horizon. Light from them could never reach us. They would not show up in any telescope, no matter how advanced. This creates an interesting philosophical situation. A theory can have excellent internal logic, can explain known observations beautifully, and can still make predictions that cannot, even in principle, be verified. This is not unique to cosmology. It is a genuine, ongoing conversation in the philosophy of science about what counts as a scientific theory in the first place. The physicists who work on these ideas are aware of this tension. Most of them are not troubled by it in the way an outsider might expect. They tend to treat it as a marker of where the frontier is. Not a failure, just the current edge of what knowledge can reach. Your breath is slightly slower than it was when you began. Not because you changed it, just because this is what the body does when attention softens and the nervous system recognizes that nothing here requires defense. It is an old reflex, older than language, older than thought in any form we would recognize as thought. The body reads the environment continuously, adjusting its own chemistry based on signals too subtle for conscious awareness to catch. Right now, it has decided on your behalf that this is safe. There is something worth noticing in that. Not the breath specifically, but the fact that your body is constantly interpreting the world and responding without consulting you. Heart rate, muscle tension, the dilation of blood vessels near the skin, all of it modulating in real time, all of it happening below the threshold of your attention. You are never fully in charge of yourself, in a biological sense. You are more like a collaboration, a conversation between different levels of a very old system. The universe, in a certain way, operates similarly. The laws of physics, the rules that govern how matter and energy behave, are not being enforced by anything external. There is no mechanism checking that electrons follow the right equations. The regularities simply hold. They have held, as far as we can tell, consistently across the entire observable universe and across all of cosmic history. The same constants, the same relationships, the same mathematics operating in galaxies billions of light years away and billions of years ago. This consistency is so complete that it is easy to forget how remarkable it is. The question of why the laws of physics are what they are is one that cosmology eventually bumps into, no matter which direction it approaches from. Inflation explains the flatness. Quantum fluctuations explain the structure. The cooling of the early universe explains the formation of atoms. Each explanation reaches back another layer. But the laws themselves, the particular values of constants, like the speed of light, the strength of gravity, the mass of an electron, these are not explained by the standard model of cosmology. They are inputs. They are given. The theory takes them as starting conditions and then describes what follows. Ask why those values are what they are, and you have stepped outside the current reach of physics. Some physicists are comfortable saying, the values simply are what they are. Other and further inquiry in that direction may not be scientifically meaningful. Others pursue ideas like the string theory landscape, where different regions of a multiverse might have different physical constants. And we find ourselves in a region where the constants permit complexity because only such regions permit observers capable of noticing anything at all. This second kind of reasoning has a name, the anthropic principle. In its most modest form, it observes simply that any universe we find ourselves in must, by definition, be the kind that permits beings capable of observation. It is almost tautological, but it is not entirely without content, and it generates real discussion about whether it constitutes explanation or merely describes a selection effect. These are the conversations at the edge. Careful people, disagreeing carefully about questions that may take generations to resolve, if they resolve at all. Here is something that often gets skipped over in the popular telling. The Big Bang is not, technically, a theory of the origin of the universe. It is a theory of the universe's evolution from an extremely early, extremely hot, extremely dense state. The distinction matters. The word origin implies a beginning, something from nothing, a moment before which there was no universe. The Big Bang framework does not actually address this. It describes what happened after whatever the beginning was, assuming there was one. It takes the early universe as its starting condition and traces forward. The question of how that starting condition came to exist, whether through some prior physical process, a quantum event, something we do not yet have language for, is not answered by the Big Bang theory itself. This is often elided in popular accounts, not dishonestly, but because the distinction requires more care than a short explanation allows. The result is that many people believe science has answered the origin question, when, in fact, science has answered a related but distinct question. Given that the universe began in this state, here is how it evolved. The origin question remains open. Some physicists find this frustrating. Others find it freeing. The honest answer is that humanity currently does not know why there is something rather than nothing. This has been a philosophical question for millennia. Modern cosmology has not dissolved it. In some ways, by describing the universe's earliest accessible moments in such precision, it has made the remaining gap more clearly defined. We know more, exactly what we do not know. There is a proposal in theoretical physics called the Hartle-Hawking boundary condition. It was developed by James Hartle and Stephen Hawking in the early 1980s, and it represents one of the most creative attempts to think about the universe's beginning in a mathematically rigorous way. The idea goes roughly like this. In ordinary experience, time is a dimension with a direction. It flows from past to future. Events have a before and after. The universe's history can be traced backward along the time dimension toward earlier and earlier moments. But in quantum mechanics, particularly in a framework that applies quantum mechanics to space-time itself, time can behave differently. The Hartle-Hawking proposal suggests that near the beginning of the universe, time was not quite the directed dimension we experience now. It was more like a spatial dimension, one that, when traced backward, did not reach a sharp edge or a boundary, but instead smoothly curved around, the way the surface of the Earth does not have an edge. If you walk south from any point on Earth, you do not fall off. You reach the South Pole, and then south becomes north, and you continue. There is no boundary, no edge, just curvature. The Hartle-Hawking proposal imagines the beginning of time as something like that pole. Not a boundary, not a wall. A point where the dimension that we experience as time gradually becomes something else, without a sharp origin, without a moment before which nothing existed. In this picture, asking what happened before the Big Bang would be like asking, what is south of the South Pole? The question does not fail to have an answer. The question itself is not fully formed. This is not presented as the answer. Hawking himself was careful about that, and in the decades since the proposal was made, theorists have found it both generative and problematic in various ways. It requires mathematics that goes well beyond what current physics can fully evaluate. It makes predictions that are difficult to test. But it illustrates something about how physicists approach the origin question at its most serious. They do not throw up their hands and stop. They look for frameworks where the question can be asked in new ways, where the familiar intuitions about before and after might be the wrong intuitions to bring. Time itself, in these frameworks, is not taken as a given. It is treated as something that emerged, or condensed, or became what we experience as time from something prior that was not quite time in any familiar sense. This is genuinely difficult to hold as a mental image. The human mind evolved to navigate a world where time is a reliable background, where there is always a before and an after, where causation flows in one direction. The possibility that time itself might have a beginning, or might not have a beginning in any conventional sense, runs against the grain of ordinary intuition, and yet the mathematics allows it. In fact, the mathematics in certain frameworks seems to require something like it. There is something about this that has always stayed with me, the quiet permission it offers to let go of the assumption that the universe had to begin in any way that the human mind can picture. The body rests more easily when the mind stops insisting on resolution. This is something sleep researchers have noted in a clinical sense, that the state preceding deep sleep involves a kind of loosening of the problem-solving orientation. The prefrontal cortex, which handles planning and analysis, and the particular effort of holding a question open while working toward its answer, quiets its activity. Not all at once. Gradually. Like a room that dims slowly enough that you do not notice the moment the light changed. Your thinking, right now, does not need to be sharp. It does not need to arrive anywhere. The question we have been sitting near: whether the universe had a beginning. What kind of beginning? What the word beginning even means at the scale of space-time itself. That question has been alive for decades among some of the most careful thinkers in human history. And it will still be alive tomorrow. It does not require resolution tonight. What it offers tonight is something different. Not an answer. A quality of attention. The kind of attention that can hold a very large question loosely, without gripping it, without needing it to resolve before the next breath. This is actually a skill, though it is rarely described that way. The capacity to be curious without being anxious. To stay near the unknown without being disturbed by its openness. That capacity is worth cultivating, and in a strange way. The very largest questions are among the best places to practice it, because their scale makes the pressure to resolve them obviously unreasonable, and so the mind can relax its solving, reflects, and simply look. In 1998, two independent teams of astronomers were studying a particular kind of exploding star, a type of a supernova, using it as what astronomers call a standard candle, because these supernovae reach roughly the same peak brightness. They can be used to measure distances across enormous scales. By comparing how bright they appear in the sky with how bright they actually are, the distance can be calculated with reasonable confidence. The teams expected to find that the universe's expansion was slowing down. Gravity pulls matter together. The expansion from the early universe should, over time, be decelerating as all that matter exerted its mutual gravitational attraction. Eventually, perhaps, it might halt and reverse. What they found instead was the opposite. The expansion of the universe is accelerating. Galaxies are moving away from each other faster now than they were in the past. And the rate of that acceleration appears to be increasing. Something is pushing space apart. Something that does not behave like ordinary matter or energy, that does not clump, that does not dilute as space expands, that fills empty space uniformly and persistently drives this acceleration. Physicists call it dark energy. The name carries essentially no information about what it actually is. It is a label for something measured but not understood. Current estimates suggest it constitutes roughly 68% of the total energy content of the universe. The majority of what the universe is made of is something we cannot directly detect, cannot characterize, and cannot explain from first principles. Dark matter adds to this picture. Separate from dark energy, dark matter is an inferred substance that does not emit, absorb, or reflect light, but whose gravitational effects are clearly visible in the way galaxies rotate and in the way galaxy clusters bend the light passing through them. The rotation of galaxies was the first strong evidence. Stars near the outer edges of galaxies move at speeds that cannot be explained by the visible mass of the galaxy alone. If only the stars and gas we can see were present, those outer stars would fly off into intergalactic space. They do not. Something holds them. Something with mass and therefore gravity, but without any electromagnetic interaction that would make it visible. Dark matter, by current estimates, makes up roughly 27% of the universe's total energy content. Ordinary matter, the kind made of protons, neutrons, and electrons, the kind that forms stars and planets and oceans, and the body you are resting in right now, constitutes approximately 5% of the universe. Everything humanity has ever studied directly, every atom that has ever been observed, weighed, interacted with, burned, frozen, split, or combined. Every star ever seen, every planet ever visited, every creature ever born. All of it together makes up roughly 5% of what exists. The rest is dark. Not metaphorically. Physically inaccessible to direct observation by any instrument built from ordinary matter, responding to ordinary forces. This is the current inventory of the cosmos, assembled from the most careful measurements humans have ever made. There is a quality to that inventory that the mind wants to rush past. 5%. The number lands, and the attention wants to move on to the next thing, because sitting with it requires something uncomfortable. A genuine revision of how large the known actually is compared to the unknown. Most of us operate with an implicit sense that science has broadly mapped what exists, that the major categories are filled in, that what remains are refinements and details. The history of science does contain this pattern in some domains. Chemistry, at the level of everyday reactions, is well understood. The mechanics of how proteins fold, how cells divide, how electrical signals move through neurons, these involve open questions. But the foundational frameworks are stable. Cosmology is different. At the cosmological level, the framework is genuinely incomplete in ways that are not details. Dark energy and dark matter are not footnotes. They are the majority of what the universe contains, and they remain, after decades of careful effort, substantially mysterious. This is not a cause for concern. It is simply the actual state of things. And there is a kind of relief available in acknowledging it. The universe does not require humanity to have understood it fully in order to continue. The galaxies move apart, whether or not anyone knows what is driving them. The ancient light continues arriving. The old questions remain open, held by the cosmos with a patience that has no anxious edge to it. Your jaw can be softer than it is, not forced, just noticed. The muscles around the hinge of the jaw carry tension that accumulates through the day without announcement, without any single moment you could point to as the cause. It is simply the residue of being a person who spoke and concentrated and responded and held various small efforts throughout the waking hours. It does not need to stay now. The shoulders, too, if they have risen slightly without your noticing, can settle. Not through effort. Through permission. Through the simple recognition that the body's holding posture is a habit, and habits release when they are gently seen. The universe we have been exploring tonight is very old and very large and mostly dark in the technical sense of unobserved. And yet here, in this body, in this particular arrangement of atoms that has been alive for some number of decades and will be alive again tomorrow, there is warmth. There is the slow rhythm of breath. There is the particular texture of whatever surface is holding your weight. These are not small things dressed up to seem profound. They are simply present, without requiring any interpretation, without pointing toward any conclusion. The vast questions and the immediate sensations can coexist without tension. They always have. Somewhere between 30 and 40,000 years ago, human beings began leaving marks on the walls of caves. Not all of them were hunting scenes or animal figures. Some were patterns, dots and lines, and geometric forms that appear with some consistency across sites separated by thousands of miles and thousands of years. Researchers who study altered states of consciousness have noted that some of these patterns resemble what the human visual system generates internally. The geometric phosphenes that appear when the eyes are closed, when the brain is in certain states of deep quiet or trance. The earliest human art may include images of the inside of the mind itself. That is a small observation, but it stays quietly. These were people looking inward and finding something worth recording. Something patterned and recurring that felt, presumably, worth preserving on stone. We do not know what meaning they attached to it. We do not know what they believed they were seeing. But the act itself, attending carefully to interior experience and finding it worth marking, is continuous with something that human beings still do. You are doing a version of it now, in a different register, attending inward, noticing what is present. The capacity for this kind of attention is very old. It did not begin with philosophy or neuroscience or any formal tradition. It was already present in the people who sat in firelight and pressed their hands to cave walls and looked, with whatever awareness they carried, at their own experience. Something in that continuity is settling rather than strange. The question of consciousness is one that cosmology eventually touches, not because physicists are required to address it, but because the universe produced it. And any complete account of what the universe is must eventually reckon with the fact that it gave rise to things that observe it. This is sometimes called the hard problem of consciousness, a phrase introduced by the philosopher David Chalmers in the 1990s to distinguish the genuinely difficult question from the merely complicated ones. The complicated questions involve explaining how the brain processes information, integrates signals, produces behavior, generates language. These are hard in the practical sense. They require enormous scientific effort. But they are tractable. The hard problem is different. It asks why any of that processing is accompanied by experience. Why is there something it is like to see the color blue, rather than simply a system that detects wavelengths and responds accordingly? Why does information processing in biological tissue produce the felt quality of being aware? This question has no agreed scientific answer. It has generated an enormous literature and a genuine diversity of serious positions among philosophers and scientists. Some argue consciousness is a product of sufficiently complex information processing that at some threshold of integration, experience simply emerges. Others argue this cannot be right, that no account of physical processing, however detailed, could explain why there is felt experience rather than mere function. A smaller number of researchers take positions, even further from the mainstream, that consciousness may be a fundamental feature of reality rather than an emergent product of it. This last position has a name: panpsychism. And while it sounds immediately strange, it is worth pausing before dismissing it, because some careful thinkers have found it genuinely compelling, not as mysticism, but as a response to a real explanatory gap. The argument runs roughly like this: if consciousness cannot be derived from purely physical processes, if there is always an explanatory gap between the description of neural firing and the fact of experience, then perhaps the mistake is in assuming consciousness is not already present in some form in the physical substrate itself. Not that rocks are thinking, not that electrons have opinions, but that the intrinsic nature of physical reality, whatever it is, that physical descriptions are descriptions of, might already include something proto-experiential, and that the rich, conscious experience of beings like us is what that basic property becomes when organized into sufficiently complex structures. This idea has been around in various forms since the pre-Socratics. William James discussed something like it. Alfred North Whitehead developed an elaborate version. Contemporary philosophers like Philip Goff have written carefully argued books defending versions of it. It remains deeply contested. But it is not irrational, and it connects in a quiet way to the cosmological picture, because if experience is in some sense fundamental, then the universe's production of consciousness is not a peripheral afterthought. It is continuous with what the universe is, all the way down. Whether or not that philosophical position is correct, there is something that remains true regardless. The universe, in producing beings that observe it, has produced something that loops back on itself. Matter arranged in a particular way becomes capable of modeling the larger arrangement it is part of. the cosmos. Through the long chain of stellar nucleosynthesis and planetary formation and chemical complexity and biological evolution, eventually produced creatures that look up and ask how it began. This is not sentimental. It is a structural fact about what has happened. The carbon in a human brain, arranged in its particular pattern of electrochemical activity, is part of the universe, examining its own history. When a physicist calculates the curvature of space-time or traces the temperature variations in the cosmic microwave background, the universe is, through that physicist interrogating itself. Carl Sagan expressed something like this in widely remembered language about being made of star stuff. The idea has become familiar enough that it risks losing its weight. But the weight is real. You are not separate from the universe, contemplating it from outside. You are a local process within it, a region of organized matter that has become capable of holding questions about the whole. The boundary between you and the cosmos you are curious about is less clear than ordinary experience suggests. The atoms currently participating in your awareness were part of other processes before, and will be part of other processes after. The particular organization that constitutes you is temporary, but the matter is continuous. The history is unbroken. This is the part where the scale of time becomes something other than a number, 13. 8 billion years is a figure. It fits on a page. It can be spoken aloud in under 2 seconds. And yet it represents something that cannot actually be held in human intuition. Not really, not in any felt sense. The mind can acknowledge the number without ever truly registering what it means. There is a way of approaching it that sidesteps the number. Think instead of one generation, a grandmother and a grandchild. The knowledge passed between them, the resemblance carried in a face, the habits inherited without knowing it. That transmission, one generation to the next, is intimate and concrete. Everyone has experienced something like it. Now let that repeat. Not 13. 8 billion years worth. Just a few thousand iterations. A few thousand grandmothers and grandchildren, laid end to end. A few thousand such transmissions reaches back to the cave walls, to the dots and the handprints, to the people who sat by fires and looked inward and found something worth preserving. And those people were already the product of an almost incomprehensible chain of prior transmission, biological, chemical, stellar. They inherited their carbon from dead stars, their water from ancient comets, their nervous systems from hundreds of millions of years of accumulated biological refinement. Every generation received something and passed something forward, including yours, including the particular configuration of matter and memory and attention that is resting here tonight, somewhere at the middle of an ongoing process whose beginning is unclear and whose end is far beyond any horizon worth worrying about now. The light in the cosmic microwave background has been traveling for roughly 8 billion years. It left its source when the universe was approximately 380,000 years old, an infant by cosmic measure, already ancient by any human one. And it has been moving at the speed of light in every direction ever since. The portion of it that reaches Earth arrives from all directions. Equally, a nearly perfect sphere of ancient radiation surrounding us completely. We are inside it. This is easy to read past, so it is worth staying with briefly. The oldest observable light in the universe does not exist somewhere out there, at a location you could point toward. It surrounds the Earth on all sides. It passes through this room. It passes through the wall behind you, and through the ceiling above you, and through the floor beneath you. Some fraction of it is moving through your body right now, as it has been every moment of your life. You have never been outside the oldest light. You were born inside it. You have lived your entire life, bathed in radiation from the early universe. This is not a metaphor for connection. It is a physical description of your actual situation. The instruments that detect require extraordinary shielding and cooling, operating near absolute zero to avoid being overwhelmed by the warmth of their own equipment. The human body cannot feel it. It arrives in the microwave portion of the electromagnetic spectrum, far below the threshold of what the eye responds to. But it is present, constant, arriving from every direction with a temperature of 7 degrees above absolute zero, carrying its ancient pattern of slight variations. The imprint of those primordial sound waves still legible after all this time. The uniformity of that background radiation is itself a clue that took decades to fully appreciate. When astronomers first mapped the cosmic microwave background in detail, they expected to find significant variation. The universe contains enormous structures, galaxy clusters, filaments, vast empty voids. These structures formed from initial density variations, so there should be variation in the background. And there is, but far less than naive expectation would suggest. The background is uniform to roughly 1 part in 100,000. This extraordinary smoothness presented a problem. Regions of the early universe that are now on opposite sides of the observable cosmos, separated by distances so vast that light could not have traveled between them even in the full age of the universe, have the same temperature to within tiny fractions of a degree. How did they reach thermal equilibrium if they were never in contact? This is called the horizon problem. And it is one of the principal motivations for the inflationary model discussed earlier. If the entire observable universe expanded from a region small enough to have been in thermal contact before inflation, the smoothness is explained. Everything we can see today was once close enough to exchange energy and reach equilibrium before being pushed apart by that. extraordinarily rapid expansion. Inflation was not invented to match the data after the fact. It was proposed first, and the data confirmed its key predictions with a precision that was not guaranteed in advance. This is what scientific confidence in a framework actually looks like, not certainty. Predictive success, repeatedly tested across multiple independent lines of evidence. And yet inflation itself remains in a curious position. The basic idea that the early universe underwent a period of exponential expansion driven by some field with particular properties is well supported by observation. But the details of what that field was, how inflation began, and crucially how and why it ended, are not pinned down. Dozens of inflationary models exist in the literature, each making slightly different predictions. The data so far has been consistent with many of them, and has not yet definitively distinguished between them. There are also physicists who question whether inflation is the right framework at all. Some alternatives have been proposed: bouncing universe models, string gas cosmology, varying speed of light proposals, each attempting to explain the same observational facts through different mechanisms. This is healthy. This is what active science looks like from the inside. The textbook version of a field presents the consensus, smoothed and confident. The working version involves genuine disagreement among careful people about foundational questions, with the data serving as the eventual referee, slowly accumulating toward clarity. The origin of the universe is a question that science is actively inside, not a question it has passed through and left behind. There is a particular kind of star worth knowing about quietly. White dwarfs are the remnants of stars, like our sun. After they have exhausted their nuclear fuel and shed their outer layers, what remains is a dense, slowly cooling ember, roughly Earth-sized, but containing a mass comparable to the Sun's, supported not by the energy of ongoing fusion, but by a quantum mechanical pressure called electron degeneracy pressure. White dwarfs do not burn. They simply cool. Over billions of years, a white dwarf releases the heat stored in its matter, gradually fading from white to yellow to orange to red. Eventually, in a time so long it has not yet occurred anywhere in the observable universe, it would cool to a black dwarf, a cold, dark remnant, invisible, still present, simply no longer radiating. The universe is not old enough yet for any black dwarfs to exist. The coolest white dwarfs currently observed are still a few thousand degrees, warm remnants of stars that burned out billions of years ago, still slowly releasing their stored heat into the surrounding dark. There is something in that image that carries its own quiet. Not tragedy, not triumph, simply the long, unhurried cooling of something that burned for a very long time, releasing its warmth gradually into the surrounding space, taking longer to finish than any human timescale can hold. your body is doing something similar in miniature, in the sense that warm things release heat to cooler surroundings. This is thermodynamics, one of the most fundamental descriptions of how energy behaves. Heat moves from regions of higher concentration to lower. Gradients equalize. Differences smooth out over time. The universe itself is subject to this. The second law of thermodynamics, applied at the largest scale, describes a cosmos in which the available energy for doing work gradually decreases. Not because energy is lost, but because it spreads, equalizes, becomes less organized. This long-term trajectory is sometimes called heat death. Not a dramatic ending, a gradual settling into a final equilibrium, where temperatures everywhere are equal, where no gradients remain to drive processes, where the conditions for complexity and life and thought are no longer present. This is very far away. The timescales involved make the current age of the universe look brief. And much could change in the theoretical picture. Before then, there are processes at those timescales that physics can only roughly sketch. But the trajectory, if current understanding holds, is toward an eventual stillness. And here is the part that does not require any comfort to be offered. It simply rearranges something in the perspective. Everything that has happened in this universe, every star that formed, every planet, every ocean, every living thing, every question ever asked about the nature of the cosmos has happened in the early, energetic, luminous phase of a universe that is still young. The period in which complexity and life and awareness are possible is not infinite. It is bounded, which means we are inside it now. This questioning, this resting, this particular arrangement of atoms that holds a life and a curiosity, this is happening during the window, not urgently. Just simply, now is when this kind of thing happens. The window is not something to hold tightly. It is simply the name for where you already are. There is no action it requires, no response it demands. The fact that complexity and life and awareness exist within a bounded period of cosmic history does not create any obligation to feel more, or notice more, or extract more from the moments available. That kind of pressure is a misreading of the scale. The universe is not asking anything of you tonight. The window is just open. You are inside it. That is enough. Your body knows how to rest within it, has always known, long before anyone had the language, to describe thermodynamics or stellar evolution or the eventual cooling of the cosmos. Bodies lay down in the dark and released the day. The same releasing is available now. The same biological settling that has happened for every human generation before yours, in every climate, on every kind of ground. The knowledge in your body about how to do this is older than any knowledge your mind contains. There is no technique required. The body does not need to be instructed. It needs only the absence of interference, the quiet permission that comes when the thinking mind loosens its grip slightly and allows the older systems to do what they already know. The word cosmos comes from a Greek word meaning order. Not order in the rigid sense, not a machine, not a fixed arrangement. Order in the sense of a discernible pattern, something that holds together, something that, examined carefully, reveals regularity rather than chaos. The Greeks who first used the word in this way were noticing something that remains true at every scale of investigation since. The universe is not random. It operates according to patterns that hold. Equations written by humans in the last few centuries describe the behavior of galaxies billions of light years away, and they describe it accurately. The same mathematics that governs the orbit of a pendulum governs the orbit of a planet. The same principles that describe the behavior of light in a laboratory describe the bending of light around a massive galaxy cluster. This correspondence between mathematical structure and physical reality is one of the quiet mysteries that physicists occasionally surface and then set aside because it has no obvious explanation. The physicist Eugene Wigner called it the unreasonable effectiveness of mathematics. Why should abstract patterns discovered through pure reasoning correspond so precisely to the structure of the physical world? No one has a fully satisfying answer. The correspondence simply holds, discovered again and again across centuries of inquiry, each new domain of physics, finding that the universe has been mathematical all along. You do not need to understand mathematics to inhabit a mathematically structured universe. The correspondence operates whether or not anyone notices it. Your heartbeat follows a rhythm that can be described by differential equations. The electrical signals moving through your nervous system right now obey the same electromagnetic laws that govern the light arriving from distant galaxies. The fluid dynamics of blood moving through vessels and the fluid dynamics of gas moving through interstellar space are described by related frameworks. You are not adjacent to the physics. You are made of it. Every process occurring in your body right now is a physical process, continuous with the physical processes of the universe at large. Not symbolically, not poetically. Literally, the same forces, the same particles, the same underlying structure. The boundary between body and cosmos is a practical one, useful for navigation, necessary for ordinary life, but not a fundamental one. At the level of the physics, there is no sharp line where you end and the universe begins. There is only matter and energy organized into different densities and structures, some of which are temporarily arranged into the configuration of a living body, and some of which is the surrounding world. This particular arrangement will last a while longer. It is not close to its end, and tonight it is resting, which is one of the things it does when it is functioning well. when the chemistry is balanced and the nervous system has shifted into its nighttime mode, and the whole system is doing what it evolved to do in the dark hours. Sleep itself is still not fully understood. This is one of those facts that tends to surprise people when they encounter it. Sleep research has advanced considerably in recent decades. The discovery of different sleep stages, the identification of slow wave sleep, and REM sleep, the gradual mapping of what the brain does during each phase, the role of sleep in memory consolidation, in emotional regulation, in cellular repair, in the clearance of metabolic byproducts from the brain, all of this has become clearer. But the fundamental question of why sleep is necessary at all in the evolutionary and biological sense remains not fully answered. It is a state of significant vulnerability. A sleeping animal cannot flee, cannot fight. They cannot forage. The fact that sleep has been conserved across virtually every animal species studied, including creatures with nervous systems, far simpler than ours, suggests it serves functions so essential that the vulnerability is worth it across a very wide range of circumstances. Whatever those functions are, they are ancient. Your nervous system has been shaped over hundreds of millions of years to enter this state reliably, regularly, deeply. The urge towards sleep at the end of a day is not a weakness or an inefficiency. It is one of the most deeply conserved biological imperatives in the animal kingdom. The body is not winding down tonight. It is entering a phase of active, essential work. Just work that does not require your conscious participation. There is a phenomenon that sometimes occurs in the transition between waking and sleep. A sudden jerk of the body, a sensation of falling, of stepping off a curb that was not there, of a stumble that wakes you briefly before you settle again. It is called a hypnic jerk, and its cause is not entirely understood, though several hypotheses exist. One suggestion is that it is a relic of an earlier evolutionary context, a response in which the relaxation of the muscles during sleep onset is misread by a monitoring system as the body falling from a perch, triggering a reflexive catch. Whether or not that specific explanation is correct, the phenomenon is common. Most people experience it. And there is something in it worth noticing tonight, not as a curiosity, but as a texture. The transition into sleep is not a switch. It is a process. The brain does not go from waking to sleeping in a single step. It moves through stages, some of which involve this kind of brief surfacing, a momentary pullback toward waking, before the descent continues. This is normal. It is the system doing what it does. The settling is not linear. It is gradual, and occasionally it eddies back before moving forward again. If that happens tonight, it requires nothing. No correction. No concern. Just the recognition that the process continues regardless, that the body knows the way down and will find it again. without assistance. The stars you cannot see tonight are still there. Cloud cover, city light, the particular angle of the Earth, these obscure them from direct view. But the light is still arriving. The photons are still completing their journeys. The Milky Way still arches overhead, whether or not the sky is clear enough to show it. The familiar stars of whatever season, this are still in their positions, moving with the slow rotation of the Earth, tracing their ancient arc from horizon to horizon. Nothing about the cosmos requires your observation to continue. This is one of those small recognitions that the mind can rest inside. The processes are ongoing without you. The universe is not waiting. The pulsars are spinning. The white dwarfs are cooling. The distant galaxies are continuing their recession. The ancient light is still traveling in every direction from its origin, all of it proceeding with a consistency that requires no maintenance, no supervision, no witness. You can be absent from the watching for a while. Everything will be exactly as it is when you return to it. The sky keeps its inventory without being observed. The physics holds without being understood. Others call the long story of the cosmos continues its next chapter through the night, through whatever portion of it remains. Into the morning, you will eventually return to. None of that is your responsibility right now. There is a quality that the best sleep has, a quality that is difficult to describe because it exists at the edge of awareness in the last moments before consciousness releases its hold entirely. It is something like trust, not directed at anything in particular, not a belief or a decision, just the body's oldest knowledge expressing itself. The knowledge that release is safe, that the systems will continue, that waking will come again in its own time. This quality is not manufactured. It arrives when the conditions are right, when the room is safe enough, when the body is tired enough, when the mind has loosened its grip on whatever it was holding. The grip loosens gradually. You may not notice it happening. The thoughts that were present a few minutes ago may already be harder to locate precisely. The edges of things have softened slightly. The quality of attention has changed without any single moment you could point to as the change. This is the descent doing what it does, not something you are causing, something you are allowing. The difference between those two is the whole of it, really. Sleep cannot be accomplished. It can only be permitted. And the permission comes from exactly this, the recognition that nothing here requires solving, that the questions can rest where they are, that the body already knows what to do next. The Big Bang, if it happened, was silent. There was no one to hear it. There was no air to carry sound. There was no surrounding space in which a sound wave could have propagated outward, because the expansion was not an explosion into a pre-existing emptiness. It was the expansion of space itself, the stretching of the fabric in which matter and energy existed, with no exterior from which it could be observed. The universe did not begin inside anything. There was no outside. Space itself was what was growing. This is another of those ideas that ordinary intuition struggles with. The image that the name Big Bang conjures, a detonation, an expansion outward into surrounding emptiness, is not quite right. More accurate, though still imperfect, is to imagine the space between all points expanding simultaneously, everywhere at once, with no center and no edge. Every point in the universe moving away from every other point, not through space, but as space. The galaxies receding from us are not moving through space away from a central explosion. Space itself is growing between us and them. The distance is increasing not because they are traveling, but because the medium of their separation is stretching. This is what the mathematics describes. And the mathematics, in this case, has been tested against an enormous range of observations and found to be accurate. The stretching continues tonight. While you rest, the galaxies continue their recession. The nearest large galaxy, Andromeda, is actually an exception. It is gravitationally bound to the Milky Way and is moving toward us, destined to merge with our galaxy in roughly 4 billion years. But beyond the local group of gravitationally bound galaxies, everything is receding. The more distant, the faster. There is a distance called the Hubble radius, beyond which galaxies are receding from us faster than light. Not because they are moving through space faster than light. That remains impossible. But because the space between us and them is growing so rapidly that the net effect exceeds the speed of light. Light from those galaxies will never reach us. They are, in a practical sense, permanently beyond our observational horizon. The observable universe, the sphere of space from which light has had time to reach us, is not the whole universe. It is the portion we can access. The full universe may be vastly larger. Some models suggest it is effectively infinite. Others suggest it wraps back on itself at scales we cannot observe. We do not know how large the universe is. We know only how large the portion is that we can see. The rest continues beyond the horizon, proceeding according to the same laws, carrying its own history, indifferent to whether it is observed or known. Your breath is slower now than it was at the beginning. The rhythm has found its own pace, unhurried, regular, the chest rising and falling with an ease that does not require attention. The air moving in is the same air that has been cycling through living things for as long as living things have existed. Oxygen produced by photosynthesis, carbon dioxide exhaled and absorbed, and exhaled again across an unbroken chain of biological processes, stretching back billions of years. The breath connects you to that chain without effort. Every exhale carries something outward, that will become part of something else. Every inhale brings in something that was recently elsewhere, in a forest, in an ocean, in the body of another living thing. The boundaries of the body, even in this most intimate biological function, are permeable. You are continuously exchanging with the world outside you. The universe is doing the same at every scale. Exchanging, cycling, moving material and energy through configurations that persist briefly and then transform. The persistence of patterns within the transformation is what we call existence. A star exists for millions or billions of years, maintaining its configuration through ongoing fusion until the fuel is exhausted and the configuration changes. A body exists for decades, maintaining its configuration through ongoing metabolism until it too eventually transforms. The pattern is real while it holds. Its temporary nature does not make it less real. A wave is genuinely a wave, even though it is made of water that was not always there and will not always be there. The shape has its own integrity. Your shape has its own integrity. Right now, tonight, resting. There is no more that needs to be understood tonight. The questions about the universe's beginning, whether there was a singularity or a bounce, whether time had an edge or curved smoothly around, whether the Big Bang was a beginning or a transition, whether the mathematics of inflation describes what actually happened or only approximates it. All of these remain open in the literature, held carefully by the people whose work it is to hold them. You have been near them tonight. That is enough. The mind does not need to carry them further. They are not yours to resolve. They belong to the long, slow, collective project of human inquiry that has been ongoing for centuries and will continue long after tonight. Your presence near the questions is sufficient. Your curiosity has been real, and it has been enough, and it can now be set down. The shoulders can be soft. The jaw can be loose. The hands can rest exactly as they are, neither gripping nor reaching. The oldest light is still passing through this room. The carbon in your bones still carries its stellar history. The hydrogen in your cells is still among the oldest matter in the universe. None of this changes while you sleep. You will wake tomorrow still made of the same ancient material, still inside the same expanding cosmos, still held by the same gravity that holds the galaxies. The universe does not require your attention to continue being what it is. And you do not require understanding to rest within it, something about that has always seemed. To me, like the quietest kind of permission, there is. Let the eyes stay closed. Let the breath continue at whatever pace it has found. Let the body be heavy against whatever holds it. The thinking that remains is already looser than it was, less attached to any single thread, more willing to drift between one thing and the next without needing to arrive anywhere. This is how it ends, not with a conclusion. just with a gradual release of the need for one. The cosmos is very old and very large and mostly unknown and continuing without pause through this night and every night. Somewhere in it, in a small corner of an unremarkable galaxy, on a pale planet orbiting an ordinary star, a body is resting, breathing, settling, made of ancient matter, briefly organized into something that wondered about its origins, and now releasing that wondering into the dark. That is enough. More than enough. Sleep well.